Alright, today we're going to be starting chapter 2, which is all about logic. So logic is kind of like how we think or how we reason, deciding if something is true or false, and hearing all of that. So like if you hear like, that just isn't logical, that means it just doesn't make sense. Oh, and this is chapter 2A. We split chapter 2 up into two parts. We have A and B. So I'll sneak an A in there. 2A. Alright, you should have gotten this glue in. If not, you might want to wait, or you'll have to just copy as you go. So you're going to glue this in. I forgot to glue with me today, so I do not have that, but that's okay. Let's try it out together. Alright, so our 2-1 is about reasoning and conjecture, and if you want to put that up a little bit higher, you want some space at the end. Okay, so we are going to decide things about reasoning, how we think and how we decide, and conjecture is about how we decide. Our conclusion. So a conjecture is a conclusion, or it can also be like a rule, something that we came up with. Okay, kind of like a suspicion, like this is what I think is happening, and we have to test and see if it works. There we go. Next up, we have this word inductive reasoning. And inductive reasoning uses patterns to make a conjecture. So today's going to be about noticing those patterns. And the big thing here is when we notice those patterns, we need to be using what we're given. So here we got the first one here. This is our first example. We're going to come up with a conjecture. So we need to come up with a rule, how this is working. And then next term means like what comes after that. What's our next number going to be? Okay. So as I look, I have 4. And to get to 10, I can't multiply. I could, it'd be by a fraction. So let's think if I add, that would be plus 6. 10 to 18 is plus 8, so that's not the same. But now I have 18 to 28 is plus 10. And then 28 to 40, that would be a plus 12. As I look at these numbers I'm adding, 6, 8, 10, 12, that tells me what I'm going to add on next. Because as I look, this is increasing each time by 2. So for our conjecture here, we're going to add 2 more. Than before. That might be a way to put it. So every time we add, we're going to add 2 more. Every time. So since I have 12, the next thing after 12 to add 2 more, 12 and 2 make 14. I'm going to think, what is 40? Plus 14. And 40 plus 14 gives us 54. So our next term, 54. Okay, next up we have more of a word problem. It says Khalid's doctor appointments are December, May, October, March. Now this ... was supposed to be over here, sorry, ... Okay, so we need to decide what is our conjecture, what's our pattern with his doctor appointments. Okay, so it starts in December. I'm going to make a list of my months over here. So it goes December, after December it goes January, February, March, April, May. So I'm just making a list of those months off to the side so I can kind of decide. So it goes from December to May. Now starting at May, we need to go to October. So May, March, April, May, June, July, August, September, October. So then it goes from May to October. So how many months are we going each time? So from December to May, it's 1, 2, 3, 4, 5 months. Then from May to October, 1, 2, 3, 4, 5 months. All right, let's just double check it. We know we have the next one is March. So I have October, November, December, January, February, March. So November to March. 1, 2, 3, 4. Oh, sorry, we're doing from October to March. There we go. That makes more sense. 1, 2, 3, 4, 5. So another 5 months. So our conjecture, our rule, is that when Khalid goes to the doctor, it's every 5 months. Okay, so we need to find the next term. So now I need to pick up on March, and I need to go 5 more months. And I can't do that in my head, so I gotta write it out. February, March, April, May, that's 1, 2, June, July, that'd be 1, 2, 3, 4, so 1 more, August. So we go March, and then we end up at August. So his next doctor's appointment is going to be in August. And yes, I had to write all that down. Some people I know you could probably just look at your calendar, or you can think about it in your head. Your choice. Alright, next up we have a little bit more of a different pattern, and we're going to draw in the next pattern here. So we need to decide what's kind of happening with that pattern. So it starts off with 1, and I have 1, 2, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So as I look at it, there's a couple of ways to think about this. One way is to think about this dot here. I use a highlighter. Like I said, I didn't glue mine in, so sorry it moved. Okay, and if that dot moved up, and then moved up, and then moved up, that's kind of one way to think about it. There's a couple ways how you can look at this. Some people look at it in rows, and some people look at it in columns. So another way then here is that this row of 2 just goes up to that 2, up to that 2. Okay, and then that row of 3 goes from 3 to 3. So every time we're adding another row underneath, and every time we add a row underneath, we add one more dot. Or a circle, you could say. Okay, now some people, they don't look at it like that. They might think of it as adding in diagonals, like you add a diagonal, diagonal. Now we're doing 3 diagonals. Some people, they look at it as columns, so it's 1, and then we have 2, and then 1, 2, and then 3. But I look at it as rows, so that's the way I did it. So I'm going to start with my 1 on top. Then I'm going to do my 2. I'm going to line that 2 up right with that 1. 1, 2. Okay, after that we have our 3. So I'm going to go 1, 2, 3. And then after 3 we have that 4. 1, 2, 3, 4. So underneath that 4, I'm going to do one more because that was the last row there. So I need to do 1, 2, 3, 4, 5. And that would be our next pattern. Alright, next up we have a counter example. So if you come up with a counter, sometimes you hear that word like when somebody is trying to make some money off of something, or they are trying to buy something, they might counter that offer. So they're going to come back with a different offer or a different amount. Okay, so that word counter really tells us to go against. So not to agree with them, we're going to counter them. We go opposite of them. Okay, and a counterexample shows us why a conjecture isn't always true. So that counter tells us why it's not always true. Remember, that means it can be true sometimes, but not always. Okay, that word always is kind of important. It's not always true. Okay, so here are conjectures, and we're going to come up with counterexamples. So we know that these aren't true all of the time. They might be true sometimes, but not all of the times. So our conjecture here is after school, I ride the bus home. So I need to think of a time that works with this after school part. This after school part is really important that we stick with that. Okay, so I'm going to stick with after school. But now I need to figure out what's a different way or a different thing I would do after school. So after school, I go to speech practice for that club. Okay, after school, did I ride the bus home? Nope. After school, I went to speech practice. So that one day that I decided to go to speech practice tells me that this isn't always going to happen. It's not always true. And you could come up with lots of other ones, so maybe come up with one that's relevant to you. If you go to a sports practice, maybe you could get picked up by a friend. Maybe your mom or dad picks you up, or someone from your family. Maybe you walk home one day. Maybe you go to the movies after school one day. Don't know. All right, now this one's more geometric. It says if segment AB is congruent to segment BC, then B is a midpoint. So we need this first part to be true. We need two segments that are congruent, but I need B to not be a midpoint. So we might be thinking of this as A, B, C, A, B, and C, and if this is congruent to this, then that would be the midpoint. That would be the middle. So I need to think of a way of doing that without it. So I'm going to start with AB. And let's say this is like 5 centimeters. If I continue to go straight 5 centimeters, then B would be that midpoint. So instead of going straight across, I can go a different direction. I can make it an angle. And then put C there. And that is also 5 centimeters. Now B is in the kind of in the middle if you're going to walk in that direction, but in between A and C, B is not in the middle of AC. So this is our counterexample because we still have two sides that are the same, they're congruent, but B is not the midpoint between the endpoints. All right, that is it for your notes today. There is a practice in Schoology.